Hey guys, this is 14.1. We are currently going to be finding the indicated integral, partial integral. My light's bad. And our integral is the integral from 1 to e of y over x in terms of x. And for partial integrals, we're only integrating in terms of one variable. So we're only integrating in terms of x. So we're going to be treating this y as a constant, which means I'm going to go ahead and move that outside so this is easier to see. That's supposed to be an x. And from here you can see that the integral of 1 over x, of course, is ln x. So we have y times the ln of e minus the ln of 1, which comes out to be y times 1 minus 0. So it comes out to be just y. That's all it is. Okie dokie, let me erase that one. Hopefully y'all were able to follow that, because you've been doing some pretty complicated stuff beyond 14.1, so I'm hoping this comes kind of naturally. So our next one, we're going to be finding the integral from 0 to 3 and 0 to pi over 2 of e to the y cosine x dx dy. So this gives us the integral from 0 to 3. The integral of cosine x is sine x. So we have e to the y times sine of x evaluated from 0 to pi over 2 dy. And this becomes the integral from 0 to 3 of ey times 1 minus 0. And the integral, dy. So this ends up just being the integral from 0 to 3 of e to the y times 1, which is integral of e to the y dy. So I'm going to skip that step of just multiplying that in. So the integral of e to the y is still e to the y. If this was like a 2y, then it'd be a 2 out here too, but it's not. And this is going to be evaluated from 0 to 3. So we have e cubed minus e to the 0. This is an equal sign. This equals e cubed minus 1. Easy peasy, right? Just simple integrals, the good old days. Let's get this erased. And the next question we'll be doing, and the last question, or example we'll be doing for 14.1 is going to be the integral of the region of 3y e to 3x dA. This might should be dv, but I'm not really worried about that right now. From 5, or negative 5 is less than or equal to x, is less than or equal to 2, and 0 is less than or equal to y, is less than or equal to 1, which tells us our limits of integration. We're going to have a negative 5 to 2, and a 0 to 1, 3y e to 3x dy dx, because I chose this on the inside and this on the outside. That's the only reason it's in that order. That, and I like doing y's first, so all you x people are just gonna have to deal with me. So we have the integral here. So we have 3y squared e to the 3x over 2 evaluated from 0 to 1 dx, and this is going to be the integral from -5 to 2. So this becomes the integral from -5 to 2 of 3 times 0, you know, is just going to end up making all this be 0, so I'm only going to worry about the 1, and the 1 just keeps that a 3. So imagine there's like a 1 squared here, minus 0 squared, times e to 3x over 2 dx. And we're just going to move that 3/2 outside since it's a constant. So here we see that our integral will be 1/3, and of course our 3/2 is still here. It still exists. This is going to be -5 to 2 of e to the 3x. Oh wait, this isn't an integral anymore. We're evaluating it now from -5 to 2. And this ends up being 1/2, because these 3's are going to cancel out, so you have 1/2 times e to the 6 minus e to the -15 . Sorry, I got my work confused a little bit up there. I apparently didn't like my -5 before, but that's okay. And this will be your answer unless you just want to have it like this. No, that's actually your answer. Unless you want to do some further simplification, but this is perfectly acceptable. It's just 1/2 times all of this. And that's going to be the end of our 14.1 video. I'm also going to be uploading a lot more of Chapter 14 today, so be prepared for that. See you guys in the next one.